Today, we're going to build a real computer that fits in your hand, then plug it into a screen, and later use it from a laptop on your home Wi-Fi. A tiny computer that boots an operating system, opens a desktop, and runs programs. Same big idea as the computer on your desk, just smaller. By the end, you'll see it working on a monitor. Optional: an Elegoo pocket screen, and a safe way for someone else in the house to open that desktop over Wi-Fi. Same home network only. Grown-up stays in the loop for power, passwords, and Wi-Fi. Kid does the building. Let's put the parts on the table. This is a Raspberry Pi. People call it a single-board computer, one board that holds the brain, the memory, and the ports. Plain version: your phone is a computer glued shut. This is a computer you're allowed to open, wire up, and learn from. It runs a full desktop operating system, Windows, browser, files, like a small laptop without the laptop shell. An Arduino is brilliant at blinking lights and reading sensors. This Pi does something different. It boots a desktop. We're pairing it with Elegoo pieces made for the Pi world, especially a small touchscreen you can add later. Elegoo doesn't sell the Pi Brain in a mini PC kit the way some brands do. So our honest kit list is Pi starter kit for the computer, Elegoo for the maker layer on top. That's the Highbot way. Name the tools clearly. Build something real. Keep the grown-up in the loop. Cold inventory. Say it out loud as you find each piece. 1. The Raspberry Pi board, Pi 4 or Pi 5. Either works for this video. 2. A case. Put the board in the case before you power it. Cases protect pins and make it feel like a real machine. 3. A microSD card. That's the tiny storage chip, the Pi's hard drive. 4. Official class USB-C power supply made for your Pi model. Phone chargers lie. Use the right power brick. 5. A micro HDMI cable. That's the skinny video plug. First time you hear it? Micro HDMI. After that, just HDMI. 6. A keyboard and mouse. USB is fine. 7. A monitor or TV with an HDMI port. That's our primary screen. 8. Optional Elegoo, the 3.5-inch Pi screen, still in the bag for now. 9. Optional, another laptop or tablet on the same home Wi-Fi for remote viewing later. If something's missing, stop and get it before you power on. First, boots hate half kits. Step 1. Case. Open the shell. Nest the board so the ports line up with the holes. Close it. No force. If it fights you, it's upside down. Step 2. Storage. Find the microSD slot on the underside. Slide the card in until it seats. You're giving the computer its memory of how to be a computer. Step 3. Dry fit the cables, power still unplugged. Micro HDMI into the port closest to the USB-C power jack. That's the main video port. Other end into the monitor. Keyboard, USB. Mouse, USB. Checkpoint. Case closed. Card in. HDMI connected. Keyboard and mouse connected. Power brick ready, but not plugged into the Pi yet. We still need an operating system on that card. That's the next chapter, and it's a parent step. Parent step. Grab another computer and install Raspberry Pi Imager from raspberrypi.com/software. Links in the description. Open Imager. Choose Raspberry Pi OS. The recommended desktop version is perfect. Choose your Pi model if Imager asks. Choose the microSD card. Before you write, open the Gear or Edit Settings panel. This is where grown-ups make the machine safe. Set a username you both choose. Set a strong password. Write it in a password manager or a paper note the parent keeps. Do not reuse the Wi-Fi password. Do not invent password 123. Optionally, set the Wi-Fi country, network name, and password so the Pi can join your home network on first boot. Kid can watch. Parent types secrets. Write the image. Wait for verify. Eject the card. Put it back in the Pi. Now power. Plug the USB-C into the Pi last. Monitor on. You should see boot text, then a desktop. If the screen stays black, check the HDMI port nearest power. Try the other micro HDMI port. Confirm the monitor input is set to HDMI. Wait a full minute. Still black? Power out, reseat the card, power in again. Checkpoint. You have a desktop. Congrats, that's a computer. If you already see the desktop, you already won the main path. HDMI is the simplest, safest way to meet this machine. Micro HDMI from the Pi. Full-size HDMI into the monitor or TV. Same idea as a game console. Want it on the living room TV for a demo? Same cable. Switch the TV input to that HDMI jack. Sit close enough to use the keyboard. This is a computer. You'll want a table. What working looks like? Pointer moves. You can open the menu. You can open a terminal or a browser. If the picture is too big or too small for the screen, that's a display setting to fix later. If there's no picture at all, revisit the last checkpoint before you touch Wi-Fi. Screens first, networks second. That's the calm order. Optional Elegoo layer, the 3.5-inch screen that sits on the Pi. This is the pocket display path. Handy on a desk, not required to finish today's build. Power off first, always. Seat the screen on the header the way the Elegoo booklet shows for your board. No bent pins, no guessing. Then, follow Elegoo's PDF for your Raspberry Pi model and your OS version. Those steps change over time. We are not going to invent pin commands on camera. Honest expectation. HDMI remains your reliable teacher screen. The Elegoo panel is a bonus once the Pi already boots cleanly on a monitor. If the little screen stays blank after you follow the PDF, pull it, go back to HDMI, and keep building. You didn't fail, you sequenced like an engineer. Optional branch. Use a laptop as the screen and keyboard over Wi-Fi. Plain words. The Pi stays on your desk. Another computer on the same home. Wi-Fi opens a window that shows the Pi's desktop. That's called VNC, Virtual Network Computing. Screen share on your house network. Rules. Before we flip any switch. 1. Same home Wi-Fi. Not the neighbors, not a coffee shop, not open to the world. 2. The strong password you set earlier is required to connect. Good. 3. We are not opening ports on the router. We are not broadcasting this computer to strangers. Family in the house. That's the whole story. Parent step on the Pi. Open Control Center, find interfaces, turn on VNC, or use raspi-config if you prefer the text menus. Reboot if it asks. Find the Pi's address. On the Pi, you can check network settings, or in a terminal run hostname-I. You'll see numbers like 192.168.something. That's a local address. It lives inside your home network. On the laptop, install Tiger VNC Viewer. That's what current Raspberry Pi docs recommend for this setup. Link in the description. Open Tiger VNC. Type the Pi's local address. Connect. Enter the username and password the parent set. Checkpoint. A window appears with the same desktop you saw on HDMI. Move the mouse inside that window. You're driving the mini computer from the laptop. If it fails, confirm both devices show the same Wi-Fi name. Confirm VNC is enabled. Confirm the password. Try the Pi's hostname with .local if your home network supports it. Still stuck? Stay on HDMI and try again later. HDMI never judges you. Tablet path, iPad, or similar. 2 honest options. Local VNC. Install a reputable VNC viewer app. Same home Wi-Fi, same address and password. Parent sets it up. Or Raspberry Pi Connect, an official screen share service you turn on from the Pi's system tray. It can be easier on a tablet browser because you don't have to hunt the local address. Parent creates and controls the Raspberry Pi ID. Kid does not freelance an account. Same safety rule. Grown-up owns the login. You're sharing a desktop with people in your household on purpose, not posting a computer on the public internet. If the tablet route feels like too many new words today, skip it. HDMI plus laptop, VNC is already a complete win. You built a computer. Here's what that unlocks. Next, build one. Open a terminal and write a tiny Python program that prints hello, then change the words. That's you talking to the machine in a language it runs. Next, build two. Add an Elegoo sensor later. Light, button, distance, and make the Pi notice the physical world. That's the bridge into robotics and physical AI. And when you want AI projects you can do at the kitchen table without a soldering iron, grab a free build from highbot.space/printables. Same curiosity, different material. The skill underneath all of this is understand the machine, keep it safe, make it do one clear thing. Recap. You assembled a Raspberry Pi mini computer. You gave it an operating system with a real password. You connected a display the simple way, HDMI. You optionally added an Elegoo pocket screen the careful way, power off, follow the PDF. You optionally shared the desktop over home Wi-Fi with VNC, same network, no open ports, parent in charge. That's a serious first machine. If this was useful, subscribe. We publish builds kids 8 to 16 can actually finish with the grown-up steps labeled. Start free with hands-on projects at highbot.space/printables. Want the fuller library? The activities pass is at highbot.space. Next time on this track, we'll teach this tiny computer to sense something in the room and make a decision. Physical AI starts with a board that already boots. You built the computer, now it gets interesting.